concrete. So that limits me to two possible tables. So my two possible tables are table 15.7 and 15.8. So my two possible tables are 15.7 and 15.8. Okay, if I look at 15.7, it goes from 0 to 900. If I look at the next one, it starts at 300. I'm at 248. Common sense says that that table has nothing to do with my problem, so I'm going to go to table 15.7. Okay, put your fingers on 248 and move 3 3/4 up and crisscross the two lines. So 248 and 3 3/4. Okay, when I do that, I end up with a curve that goes on a leader, 12 4 number 8s, 2.19%. 12 4 number 8s, 12 4 number 8s, 2.19%. There's my answer. And I'm done. Okay, I want to show you what this, why only one number? It's only got one number. It's a square. If you got one side, you got the other. So it's a 12 by 12. Okay? Okay, the only other thing you might need to know is I got 4 number 8s is how do you get this guy right here? How do I know? That is the percent of steel based on the gross area. So if I have a gross area, 12 by 12, I got 144 square inches. If I have 4 number 8s, if you go back to page 416 of your text, and you look up in that table the area of a number 8 bar, I get 0.79 square inches. Okay? So if I've got 4 of them, and each one is 0.79, all I've got to do is take 4 times 0.79, and I get 3.16 square inches of steel. Okay, so if I'm looking for percentage of steel versus gross, all I've got to do is take the area of the steel and divide it by the gross area of the system. And if I put 3.16 divided by 144, clear, 3.16 divided by 144, this is what I get on my calculator. That's in decimal form. To get it in percentage, I have to multiply it by 100. So if I move it over and make it a percentage, 2.19, that's exactly what they wrote down. Why do I need that? Code has a percentage limit on steel versus concrete. So it's got bracketed limits. So if you go to the ACI code, American Concrete Institute, and you look it up, it's going to tell you for a concrete column with a certain compressive strength of steel or of concrete and the strength of steel, the combination of the two, they're going to have brackets. They're going to tell you you've got to have the steel has to have a minimum of this percentage and a maximum of that percentage in to meet code. So this is a number that engineers and designers would use to make sure that the steel percentage fits the ACI code. So that's that one. The second one, the rest are going to be pretty quick, okay? We're not going to take a whole lot of time. So if you go to 15.3F, let me find it here. I'll be with you in a second. 15.3F. We need PU and we need MU. So let's take a look at it. I'm using F, so that's A, B, C. That's the last set of data. 5,000 is our concrete, and the last set of data is this. P live load, 150, dead load 200. And if I move to the right, 100 and 100 are M. So there's my data. So why don't you go work a little bit ahead of me, and I'll catch up with you in a couple seconds. See if you can pull this one off. Okay, I'm going to take and find PU. 1.6 times 150. 1.2 times 200. Run it through my calculator. 1.6 times 150 plus 1.2 times 200, I get 480. My next one is going to be MU. 1.6 times 100 plus 1.2 times 100. 280 foot kips. Moment. Now, every semester, students get in a quandary here. They end up flipping things around. Just remember, moment equals force times distance. Okay? Somehow, I don't know how it happens, but they get all screwed up. 280 foot kips equals 480 kips times E. If I divide it, I got 280 divided by 480. 280 divided by 480 gives me 0.58, a bunch of threes. Feet, if I multiply it by 12, I get 7 inches. The two pieces of data I need to enter the table, and this one's a rectangle with 5,000 as PU, 480, E of 7. Find the proper table. See if you can find it. This will be part of the next test, okay? I'm going to go find rectangles. So my only choices are 15, 11, and 15, 12. The problem statement says use concrete of 5,000. 1511 is 5,000, 1512 is 6,000. The only table I can possibly use is table 1511. Put your finger on 480 and 7 and see what you get. See if you get the same thing I did. 480 and 7. 480 is almost 500, and 7 is halfway between 6 and 8. 480 and okay, I'm going right here, and I'm going to follow that up. I get a 14 by 20, 6 number 9s. 14 by 20, 6 number 9s. 14 by 20, 6 number 9s. And the percentage on that one is 214. That's what I'd like to see on the test. Write that down. I'll give you spots to put it in, but there's a choice for the rectangular column. And the last one, round. Okay, I'll get rid of this stuff so it's not in our way. You can go ahead of me a little bit if you would. See what you get. This is a round column. If I go to the data, and I am doing I. So I is the last set of data again, 150, 200. And hopefully you got those numbers in your head already. We just did it. Hopefully you've got 1.6 times 150 plus 1.2 times 200. You've got 480 in your head there. We just did it a few seconds ago, so this should be pretty fresh. Moment, 1.6 times 100 plus 1.2 times 100 gives me that 280 I just had. Moment equals force times distance. 280 equals 480. E equals 0.58, bunch of threes, 7 inches. There's only one table for a round column. Go to that page. Round, page 415. Put your finger on 480 and 7. 480 and 7. Boy, that's pretty close to a curve. I like the curve that goes to 20-inch diameter, 8 number 11s. 20-inch diameter, 8 number 11s. And if I look at it, 8 number 11s, 3.97%. So if I looked at that and I walked out in the field, I saw that on the drawing, and I walked out there, what would I hope